In this video, I will provide a quick introduction to isocost lines and microeconomics. So if some firm wants to produce some good, it will cost a certain amount of money to produce that good. And the equation that we can use to model the total cost is this equation right here, which is called an isocost equation. And the equation is C, the cost, is equal to W, the cost for each unit of labor, times L, so the total units of labor, plus R, the cost for each unit of capital, times K, the total units of capital. So consider the following scenario. Let's say that we have some factory that produces shoes. Let's assume that the cost for each worker in this factory, W, is $100 per day. And let's say that we hire a total of L is equal to 4 workers. So our units of labor is 4. And then let's assume that R, our cost of capital, is $200 per day. And let's say we have a total of K equals 3 units of capital. In this case, let's say there's 3 machines. To figure out our total cost, we can use this equation right here. So we'll say C is equal to W, which is 100, times L, which is 4 workers, plus we have R times K. So R is 200 times K is 3. So our total cost will be 100 times 4, that's 400, plus 200 times 3, that's 600. So 400 plus 600, that is $1,000, let's say. So if we were to plot this on a graph, let's say we create a graph where the y-axis shows the units of capital and the x-axis shows the units of labor. We saw that we're using 4 units of labor, so that's 1, 2, 3, 4, and then 3 units of capital, so 3 machines. So that's right about here. So at this point, our cost, I'll say C, is equal to $1,000. Now something that we can do is we can draw an isocost line, and that's a line that shows every combination of capital and labor that has the exact same cost. Now to draw this line, there's 2 things we need to find. We need to find what's the y-intercept, so where does this line cross the y-axis, and the x-intercept. Now to find these points, it's pretty straightforward. To find this point right here, notice that on our graph, this is the point where labor is equal to 0. So there's no labor, but there's a certain amount of capital. So what we can do to find this point is we can use this cost of $1,000 and we can plug it in for C right here, and we can set our labor value, this value right here, equal to 0, and we can solve for capital. So we'll say the cost, 1,000, let's say 1,000 is equal to, we're going to use this equation again. So W, that's $100 per day, times L. Remember we said let's set L equal to 0, and we're going to figure out what our K value is. So we'll say times 0 plus R times K. So R is 200 times K. So we're trying to figure out what K is. So we get 1,000 is equal to, this is just 0, so we're left with 200K. And to solve for K, we can divide both sides by 200. So we get 1,000 divided by 200, that is 5. So 5 is equal to, over here we're left with K. So when labor is equal to 0, capital is equal to 5, which is right here. And what this tells us is that at this point right here, the cost is also equal to $1,000. So in the scenario where we use 5 units of capital and 0 units of labor, our cost is still $1,000. Now lastly, let's figure out what our x-intercept for this line is. So to find that, this is the point where capital is equal to 0. So we'll say, let's set $1,000 equal to, we'll use this equation again, but this time we'll set capital equal to 0. So we have W times L, so again that's 100 times L, plus we have R times K, so 200 times, we're going to set K equal to 0. So this will just be 0. We'll have 1,000 is equal to 100L. To solve for L, we can divide both sides by 100. And we end up with L is equal to 1,000 divided by 100, that's 10. So our x-intercept is going to be at 10, which is right here on the x-axis. So what this means is when we use 10 units of labor and 0 units of capital, our cost is also $1,000. So what we've done is we found 3 different combinations of capital and labor where the cost of each combination is $1,000. So what we can do now is draw a line that connects these 3 points. And this line represents our isocost line. So every combination of capital and labor on this line is exactly equal to a cost of $1,000. Now, we said that this particular isocost line, the cost is $1,000 for every combination on this line. But there's actually an infinite number of isocost lines that we could draw. So for example, here's another isocost line where the cost of every combination of capital and labor is only $600. And what's interesting about these isocost lines is that the slope of every isocost line is going to be equal to the negative cost for each unit of labor divided by the cost for each unit of capital. So in our example, we saw that the cost for each unit of labor was 100, so that would be negative 100 divided by the cost of each unit of capital was 200. So 200. So negative 100 divided by 200, that's negative 1/2. And that is the slope of this isocost line. And another way to frame that is that slope is rise over run. So we can see that to go from this point on the isocost line to this point, we go down 2. So the rise would be negative 2. And we go over 1, 2, 3, 4. So the run is 4. So negative 2 over 4, that's the same as negative 1/2, which again is what we just found right here. And we'll find that for every isocost line, so even for this line right here, the slope is also negative 1/2. So that is the idea behind isocost lines in microeconomics.